All right, page 2. I filled in a couple things here. Let's talk about it. I can solve an absolute value inequalities graphically. We're about to do that. Let's talk about a few things. When solving absolute value inequalities, we think of them as comparing two functions, f of x and g of x, where f of x is the absolute value and g of x is the constant, right? So we'll be talking about that very, very soon here. All right. A function whose value is the same over its entire domain is the constant function, and this is a horizontal line, which we're going to show you when we graph 4 down here. We're going to graph g of x equals 4. There's two cases, right? If f of x is less than g of x, then the absolute value graph is beneath the line. That's what makes it true. And if x of x is greater than g of x, we're going to have the absolute value graph above the line. That's the solution set anyway. So here we go. We're going to go right here, and we're going to say f of x equals the absolute value of x plus 3 plus 1. We're going to graph everything on the left side, and then we're going to make g of x 4. Alright, so we're going to go up to 4 and draw a straight line. That's the constant function, g of x. Now we're going to graph this guy, which looks to be left 3 up 1 with a slope of 1. Left 3 up 1 with a slope of 1. No real horizontal stretch. Looks like that. And looks like that. And our solution set is everything above the line. So starting at 0 but not 0, so x is greater than 0. I'm just going to write solution. Alright. And x is, well, less than negative 6. Less than negative 6. Those are our solutions to this, just judging by the graph. This says, when am I greater than 4? Well, I'm greater than 4 over here and down here. Let's do one more here. Alright. So we're going to write f of x, that left side, is equal to the absolute value of x minus 2 minus 3, and g of x is now equal to 1. Let's draw that constant first. Let's draw that horizontal line at 1. And this is 2 right and 3 down, so 2 right and 1, 2, 3 down. And once again, a and b are both 1, so it's a slope of 1 this way, right? And it's a slope of 1 this way. This time it's everything beneath the line, right? So from here to here, we've got this less than, and we're doing this disjunction. Not a disjunction, but a continual solution from negative 2, not including negative 2, right? So I'm going to say x is greater than negative 2. I'm beneath the line, beneath the line, beneath the line, all the way up to here to 6. X is less than 6. All right. Suppose, think about it, what if we changed it to this? Notice that this is almost the exact same as this, except the equal sign. How would the solution change? We would include the 2 points, right? We would include 0 and 6. 0 and 6. Suppose a graph in absolute value lies entirely above the constant. Oh, what would the solution of f of x be greater than? And what about f of x? So let's think about that. What if I have this, and I have a line here, and an absolute value that's totally over it, like that? Well, greater than, it's always greater than. Let's say that's g of x. I'll even write it as g of x, and this is f of x. And if it has to be greater, then it would be all real numbers. If it has to be less than, well, then this absolute value never goes less than. So we'd say no solution. Alright. We are about done with this page. I'm going to leave you to do this. Alright? Try that one without me. Just think about how to graph it and go. That's page 2.